Okay, so we're working on this assignment. We did this in class. This was like a notes assignment, and it's also kind of your notes and your homework. So the goal is we were trying to finish it in class. We pretty much finished it in class, so this is for you guys that missed today. We're going to jump to page 2 here of this assignment, counting permutations and combinations. We just did the front page. If you missed the front page, you can go back one video and check that out. But we're talking about this stuff right here, okay, factorial. So if you look kind of down here, it has 5 exclamation point. Let me zoom in a little bit for you. Okay, now the way you pronounce that is not like 5 with like emphasis. The exclamation point here is not for emphasis. It's actually an operation. Our operation is like a plus or minus or multiply, divide, or square root. It's something that we do to a number. So factorial is an operation using repeated multiplication of descending integers. Make sure I'm spelling everything right. Writing and talking at the same time is sometimes challenging for me. Okay, an operation using repeated multiplication of descending integers. So 5 factorial, that's how you say this, 5 factorial. What that means is 5 times 4 times 3 times 2 times 1. Okay, so descending, they're going down, 5, 4, 3, 2, 1, but you multiply them all together. All right, so 5 times 4 is 20, 20 times 3 is 60, 60 times 2 is 120, and 120 times 1 is 120. Okay, so that's 5 factorial. Okay, 8 factorial will be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And that's probably a little bit bigger than I can handle. So let's jump to our calculator. Do that really quick. So 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, so 40,320. All right, now some of what you're going to see today, it may not make sense just yet why we're using factorials and why they're important. We're just practicing just the factorial part all by itself because we're going to use them later. So I'll explain what these are for in the next video. But one of the things you're going to run into is something like this. So you can list this all out. This part we're going to expand and evaluate. Expand means like list it all out in all of its glory. So there's 7 factorial, okay? And then 3 times 2 times 1. So if you can't see that, that's 7 factorial over 3 factorial. What's going to happen here is this 3 is going to cancel with this 3, and this 2 is going to cancel with this 2, and this 1 with this 1. And that just leaves us with 7 times 6 times 5 times 4. So if you want to count down from a number, but you want to stop, you can write it kind of like a fraction, and you can say, okay, 7 factorial is going to count down from 7. But I want to like get rid of everything 3 and below. That's how you say this. So when you look at this, you might just be able to, like, without even expanding, you could see, okay, this is going to go 7, 6, 5, 4, and then after 3 it's going to stop, or 3 and below. So we'll finish it up. 7 times 6 is 42, right? And 5 times 4 is 20. So 42 times 20 would be 840. All right, now see if you can predict without even trying what this is going to be. So that's 6 factorial over 4 factorial. These came out really small. Let me zoom in. So what this would be is it would just be 6 times 5. So count down from 6, but when you hit 4, throw everything else away. Now if you want to see that, you can write it out. And that's what we're doing. We're expanding here because we just want to like look for some patterns. So 6 times 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1, right? Again, the 4s are going to cancel, the 3s are going to cancel, the 2s, the 1s, and there's my 6 times 5 that I was talking about. So when you see a fraction like this, you're like, okay, the 6 factorial is going to count down from 6, but the 4 is going to stop it, and so it doesn't all go all the way down to 1. So 6 times 5, okay, stop. Right? That's what's going on here. So this ends up just being a 30. All right, now we got to evaluate. So these ones we're not going to expand all the way. We're going to expand it a little bit just so we can see what's happening, but some of these we can kind of do shorthand. All right, now 1 factorial, you probably know, is just 1, right? That kind of makes sense. Now this is weird. 0 factorial is actually 1 as well, and that may not make sense, but I can explain that for you really quick. So let me grab a scratch piece of paper, and we'll talk about why that's the case, okay? So we'll go over here. All right, when you have powers, like let's say you have 2 to the 4th power, okay? That's 2 times 2 times 2 times 2, which equals 16. Okay, if you have 2 to the 3rd, that's 2 times 2 times 2, which equals 8. 2 to the 2 is 2 times 2, which is 4, and 2 to the 1 is just 2. If you look at the pattern here, every time we drop a power, we're dividing by 2. 16 times 2 is 8. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. So to continue that pattern, 2 divided by 2 is 1. And so we know that 2 to the 0 is 1. This is the 0 exponent property that we've talked about. Okay, well how does that apply to factorials? Same kind of idea. If we have, let's say, 4 factorial, that's 4 times 3 times 2 times 1, which is equal to 24. If we have 3 factorial, that's 3 times 2 times 1, which is equal to 6. 2 factorial is 2 times 1, which is equal to 2. 1 factorial is going to be 1. Now let's look for the pattern so we can extend the pattern. What's happening here? Well, notice here I have a factor of 4 and here I don't. So if I divide by 4, I get 6. Okay, here I have a factor of 3, but I don't down here. So I basically am dividing by 3 to get here. Okay, now this has a factor of 2 and this one doesn't. So basically I'm dividing by 2. So divide by 4, divide by 3, divide by 2. How would I get from here to here? I would have to divide by 1. 1 divided by 1 is 1. So it's kind of a similar idea to the 0 exponent property. Basically, everything is like kind of canceling out, but when you cancel stuff out in terms of multiplication, you're not left with 0, you're left with 1, right? So anyway, that's kind of what's going on there. So 0 factorial is actually just 1. All right, continuing here, we have 100 factorial over 98 factorial. Let me zoom in. Okay, now you might be thinking to yourself, that's crazy. 100 times 99 times 98 times 97 times 96 times 95, that's going to take forever, right? Well, no, that's actually not. Check this out. If you go start writing this out, you got 100 times 99, and then the rest of it is just 98 factorial. Because if you write 98 factorial, that's 98, 97, 96, 95, 94, 93, 92, 91, all the way down to 1. So this right here is 100 factorial. I don't have to expand it all the way. I just have to expand it enough so that I can cancel with what's on the bottom. Because this is also 98 times 97 times 96 times 95 times 94, all the way down to 1. So really, what's happening here is all of these numbers, now this represents 98 numbers, and all of these are going to cancel each other out. And I'm really just left with 100 times 99. So I don't even need a calculator for that one. Now again, this kind of, this idea when you have a division or like a fraction, you can kind of think of it as like your start and your stop. So it's like start counting down from 100, and when you hit 98, you're done. Like don't even go to 98. 98 and below, you're gonna throw away. So that's kind of what's going on here. Now sometimes you're going to see something like this, which has 2 factorials in the bottom. Okay, so again we're going to expand, but only as much as we need to. 12 times 11 times 10 times 9. Notice there's an 8 factorial in the bottom, so I'm just going to stop at 8 factorial, and this is the rest of it. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, now I do that, I stop at 8 factorial because I have an 8 factorial in the bottom, and I don't want to bother writing all those out because I'm just going to cancel out with this 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So I just canceled out 8 numbers right there. Okay, now I still have this other 4 factorial down here. I'm going to simplify that. So I'm going to write it out. I'm going to expand again. Okay, and now I'm going to look for common factors. So notice that 4 times 3 is a 12, so I have a 12 over 12, so that's gone. And 10 is 5 times 2, so I have a 2 over 2. That's going to leave me with a 5 there. So really, when all is said and done, I have 11 times 5 times 9. Let's punch that in my calculator real quick. Okay, that equals 495. All right. So that's how you handle factorials. Now you can use a calculator for that. Let me show you how it looks on mine. Okay, notice over here there is an X with a little exclamation point. That's my factorial button. Okay, so if I wanted to do, say, 12 factorial, I can do 12, and then I'm going to go Shift, and then this number right here, and that's a factorial, and then I got this big number. Okay. Now, I recommend that you don't use your calculator as a crutch. Okay, that's my advice to you. What I did here, I used my calculator a couple times, but I didn't rely on my factorial key. I relied on my understanding of multiplication and division. So, if you use your calculator too much, then you're not going to practice your multiplication, and you're not really going to understand factorials at like a deeper level. You're just going to be constantly like kind of shortchanging yourself. So a calculator is a tool that you can use, but you kind of want to like learn how to do it on your own, or as much as possible on your own, without running to the calculator for help. Think about if you were teaching somebody to add, and they're like, well, why do I need to learn how to add? I can always have a calculator, right? You can just use a calculator. So yeah, you can, but do you want to go through your whole life, relying on a calculator to add? Some things you'll just understand better if you learn how to do it by hand, and then when you use your calculator, you're really just like using it as a tool you already understand deeply. Okay, that's all I'm going to say about that. When we come back, we're going to talk about permutations, which is the next little bit of this assignment.